In this lecture, finally, we'll learn about yarn. Okay, so in MapReduce 1, we faced one problem that job taker have to do many things. It's in that MapReduce 1, job taker have to do. Job tracker is doing monitoring, 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 monitoring plus, sorry, monitoring plus scheduling. Scheduling. So that is the doing in there. That is the work of a job tracker in MapReduce 1. Because there is one single job tracker and multiple there is one single job tracker and 4K uh, task tracker. That time we are getting bottleneck. That is the issue. So that's why in Eon they introduce one thing. They introduce three things. Okay. So in Eon, you have a three component. One, resource manager. Okay, one is resource manager. Resource manager. Two, this video is continuation of previous video. So if you're directly watching this video, you may be not able to understand. So you have to watch previous video to understand this video. Okay. So the EN have three component: resource manager, node manager, and three is application master. Three is application master. So resource manager, this is also master slave architecture. Resource manager your master. Okay. And this is a slave. This is slave. This is slave. So if we try to map with MapReduce 1, so the resource manager we in MapReduce 2, what we made changes in latest yarn architecture in latest MapReduce 2 we introduced this yarn. So what we do, we change the name. Okay, so previously we know that is a job tracker. Now this job tracker name change into resource manager. Okay, so we change the name. So previously name was job tracker, now the name is resource manager. Previously we know task tracker. So node manager is a task tracker. Okay, you can say node manager is a task tracker. And we new and one new concept we introduced. This is called application master. And why you are doing this? Now I will tell you why I am doing this. Why they are doing like this. So we know that in previous MapReduce architecture, one architecture, when we don't have VN, that job tracker is doing two things: scheduling plus monitoring. Now this resource manager, I mean, in this now Yarn is a resource manager is like our job tracker in Yarn. This is, you can say, job tracker. So to reduce the workload of job tracker, now resource manager is only doing scheduling. Scheduling. So previously it is to do job tracker is to do scheduling plus monitoring. Now we are not doing. We are now resource manager is only doing scheduling the job. Okay. So remember one thing: the new name of job tracker in Ian is resource manager. So you change the name. Okay, and also we change some functionality, like what actually the responsibility of that part, job tracker. Now we are trying to reduce the responsibility of job tracker so that the workload is reduced. Okay, so now research manager is only scheduling the jobs. Then who is monitoring the jobs? Now we and now the application master aim, we can say application master came into picture in, and it is monitoring the every jobs. So it is monitoring the every jobs. Okay, and what is task taker doing now? Now we change the task taker name to node manager. What is doing? Since this task taker will try to monitor the container or the node in which in if you know about task stacker. Stacker used to monitor the data node. Same like this. Now we are saying node manager will monitor a particular node and send the information like what resources is being used, how many resources are used, how many resources is used in that container, how many resources is free, so that we can use for a next job, something like this. Those much information, those information is sending back to application master. So it will try to give you, if it will try to monitor the nodes. So node manager, it is trying to monitor the nodes. So if you want to know more about this, you can go here. See, so I'll go this. This resource manager is that hmm, resource manager. You can see resource manager is a demo yarn. Resource manager daemon of the yarn responsible for is responsible for resource assignment something. You can read those things. Your node manager. It register with the resource manager. We monitor the resources, performs log management, also kills the, okay, it is monitor the resources of that node. I'll explain this application master container. You can go through this article. It is very good, very good article. Hadoop architecture. Okay, I'll add this link to my uh, to this description of this video. Okay, I'll add this link. You can find this link in my description box. So this is the AN. Now I'll explain you this architecture. If you see, I'll explain this architecture. What is actually doing this client resource manager and application master. Okay. Now come to whiteboard. So I'll draw the diagram. One thing I want to say: if there is a one job, if there is a we are client assigning one job. So client submit one job in our terminal. For that, resource manager will create one application master. Okay. Now application master will create node manager. Okay. So for if there is 100 jobs, 100 application master will be created. Remember one thing, very important question interviewer can ask. If there is 100 job, to run 100 job, we need 100 application master. So in Yan architecture, application master plays very big role. Now I'll draw this diagram. What actually happening? So we have client. Okay. If you go to this, client is there. Okay. We have client. We have client. Client is submitting jobs. Okay. 1 minute. Client will have to submit the job. Okay. So client will submit the job. It will come to resource manager. When some client is submitting you, it will come to resource manager. Resource manager. Now what resource manager will do? So resource manager will start one application master inside a container. So what will do when application is submitting a job? So application will tell the client will tell I want to run this job. Okay. So then that type resource manager will create one container. Container means with some memory, with some CPU, with some RAM. Okay. Container means like on virtual machine they will create with some resources, CPU, RAM, and storage. So it will create one container that will called application master. Application master. It will create application master. Okay. It will create application master. Now what application manager will do? Now resource manager will tell that I want to execute this job. Now tell me how much resources you need for this job. Okay. So when client submitting job, it will come to here, and client and then resource manager will create one application master to monitoring the job. And application master application job of the application master is it will try to evaluate that job, the how many node manager, how many resources is needed to execute that job, and according to that resource manager application master will request that I need 3 node manager. Okay. So if so application master will tell application will send some request that I need that this much of resources to execute this job for execution of that job. And according to the request of application master, resource manager will allocate those resources. So if to execute this job we need 3 node manager, 3 container, and resource manager allocate this. Then resource manager will resource manager will scheduling those jobs in different node manager. This is a node manager. Node manager is like a container. Okay, inside the container there will be a node manager. So the job is of node manager is, it will be node manager 1, node manager 2, node manager 3, ND3. So job of node manager is to manage that node, to manage the container. Okay, how much resources are left, to monitor those things. Okay, and node manager and application master will be always in connection. What I mean, what I'm trying to say, node manager always try to send one heartbeat signal to application master that I am alive, I am okay. This is my status of my node. This much resources using this type of task is going on. This so node manager will try to always send one heartbeat. If some node failed, if for 10 seconds or for some time of period, some time period is there, if application master don't get heartbeat from this node manager, then application will say that this node is dead. It will create another node to start the tasks. That's it. So here we are trying to like in EN architecture we are trying to minimize the workload on the resource manager. Now it is only scheduling the job. Not in previous MapReduce one this is doing scheduling plus monitoring. Now this is only doing scheduling the job. That's the benefit we are getting here. And we also I'll tell you one thing on now to summarize this. Okay. So in we already we know what is the benefit. Resource manager is doing only doing scheduling thing. Application master is doing monitoring, and node manager is only managing that particular node where the task is executing. So application master, so it will schedule the job. Application will request for the node, I need this much of node to execute the job, and then after so that those this container will be allocated by resource manager. Now resource manager will execute those jobs here, and the job of the node manager is to monitor those tasks. Okay, how it's going on, it's failing or not, it is successful or not. So the node manager will try to send this information to application master to this. Okay, sorry, application master only, because resource manager only scheduling, not monitoring. And we know that this in MapReduce 2, I mean, it means Hadoop architecture 2, we introduced this CN architecture. So to use after introducing this yarn architecture, yarn in MapReduce 2, what type of benefits we are getting? Try to now we will analyze that. Key we have introduced this yarn architecture, yarn in our MapReduce 2. I mean Hadoop 2 architecture. And after introducing this yarn, what type of benefits we are getting? So now we'll summarize. Okay. So one thing, scalability, ability, scalability. So now the scheduling is doing. Who is scheduling? Scheduling. Research manager is doing scheduling. Is doing. Is doing scheduling. Scheduling. Then what is doing? One thing we're doing, and two thing, and application master is doing. Application master is doing monitoring of the job. Monitoring monitoring of the job. And however in MapReduce version we can have other job also. Okay. Only they are in MapReduce 1 we can have only one job, MapReduce jobs. Now we can have some graphs job will be there. Graph Spark Test, those jobs will can be there. So one thing in in uh, now in MR2 or Hadoop 2, Hadoop Vidian can have other jobs. I mean Tej, Spark, ARK Spark, those things, and graph. So this job we can have in Hadoop Vidian or MapReduce 2. Also we have other benefits. Let me write. And there is one disadvantage in MapReduce 1 is there, the resource utilization, because we are fixing the slots map this much of MapReduce tasks and 50 if in a cluster we have a 50 MapReduce 50 map tasks and 50 reduce tasks. So every time we're fixing that. But in the MapReduce 2, I mean in Hadoop with yarn Hadoop architecture, here we are introducing container concept, logical container concept. Okay, so with the concept of logical containers coming, the resource allocation is very much dynamic. Okay, and we can request for any amount of CPU or memory. Okay, if we need to execute, so think if we have a job with 200 map and 200 reduced tasks, so application master can dynamically request that I need this much of node manager. There is no fixed slot. Okay, so we can use the resources as per our requirement. There is no constant. So that is the one very important thing in Hadoop 2. Or this is the one main point in MapReduce 1. I mean Hadoop 1 architecture. This is the one main point. Now this is not a main point in MapReduce 2. So let me write this thing. Resource utilization. Resource utilization. So with concept of logical container, logical container coming, Now you are going to coming. What we can do? The resource manager, the resource manager, the the resource manager can allocate resources dynamically for tasks execution. Okay, that is the one main thing. Okay, there is no constraint, there is no restriction of resource utilization in MapReduce 2, I mean Hadoop 2 architecture. So that's it in this video. In next video, I will explain you Spark architecture. Okay, okay. Next video we will explain Spark architecture. Okay, Spark architecture in next video. So if you like this video, just hit the like and subscribe button. We'll see you in the next video. Bye.